Assalamu alaikum. So in this video I will be solving lab 5 which is about an introduction to JUnit. So it says download the starter code of lab 5 from the course website, unzip the file and so on. So this is the project, this is the starter code. So I need first to create a workspace. You may have already your workspace, so you can just import or copy your that project into your workspace. Then I will open Eclipse. Okay, I will open Eclipse and then I will be pointing Eclipse to that workspace. Okay, so normally Eclipse will open in another workspace. So this is it. I will just switch workspaces. So it's on my desktop. This is the new workspace I just created. Okay, so Eclipse will restart. Then I will have to make some modifications in the layout, in the appearance of Eclipse. It has a very bad dark mode. Okay, so now it says we will create test cases for the class stack. Okay, so we already apparently have a class stack. Add a test class to your project. So this is it. So here we have to import our project as an existing Maven project, okay? Because it's a Maven project, so you need to know about that when you want to import it. Okay, so here you have to point to the containing folder. You can click here and click on select folder. If it's a main project, it will be detected, so you can import it. You can check the pom.xml to see what dependencies we have. So here we have JUnit. Okay, so all of these are about JUnit. Okay, so let's go back. Then we have the class. Okay, we have this class stack. Okay, it has a push and a pop method. Okay, and then in src/test/java we don't have anything. Okay, so let's go back. So add a test class to your project in the folder src/test/java. Create a new class stack test. Okay, so any test class that you create, it has to have the name of the class you want to test, plus you have to add test. Okay, so and it has to be in this parallel folder. Okay, so here you have src/main/java, here you have src/test/java. it has to be exactly in the same folder, in the same package. Okay, so I will create here a new test class. It has to be called stack test, and the package has to be the same. Okay, then we have to import these JUnit classes assertions. We can do this later. We can start writing our code and then we can import these automatically. So note, in Java the import static statement is used to import static members, okay, of a class, so that you can access them without qualifying them with the class name. Okay, so we want to use assert equals. It's a static method. Okay, to use a static method you have to use the name of the class dot the name of the static method. Okay, so you should do this normally when you call it you have to do this assertions dot assert equals, okay, but that's too long, so that's why they added this keyword here, so that you can import static methods and you have access to them directly without having to write the name of the class before the name of the method. Okay, so create a test case to test if a sequence of push push pop pops correctly the latest push element. Okay, so if we do push push and then pop, the popped element should be this A element. Okay, so first of all we have to create here, we have to create a private stack. It has this constructor, so it will have an initial size, initial capacity of 10. Okay, then we'll create our first test case. So public void test push pop sequence. So we have to say that this is a test. Okay, so we have to import it. Okay, this is the first import, the second import, and here we have to use the stack dot push stack.pop. We can make it more complex, but this is just for testing. Sorry, this is also push, and then we will assert equals means make sure that these two things are equal, A and what is popped by the stack. Okay, so what is popped by the stack should be equal to assert equal to the to this string here. So this we have to import it, so add static import to assertions assert equals. Okay, so now we have this import. We can also, if you want to use all the asserts that are inside this class, we can add the star here instead of assert equals. Okay, so now right click on pom.xml and execute run as Maven test to see the result of the test. Okay, so now we click here and then we run as Maven test to see the results of the tests. So we should see that we have tests. Okay, so we have here our tests. You can see that one tests have been executed, 0 failures, 0 errors, 0 skipped. Okay, so everything is working fine. If we try to put an S here, okay, so we just want to make sure that a test fails. So here if we test again, the build should be blocked. Okay, so the build is blocked. Why? Because there was a test failure. Okay, so that's the advantage of testing. Before you build your software, you create the executable, the jar. Before that, you make sure that all your tests they succeed. Okay. then we have add other test cases. So we will add this test case here. So this test case what is a way to make sure that an exception is thrown. Okay, so this is the class. Let's look at the class. Here you have, when you pop from a stack that is already empty, elements is empty, no such element exception should be thrown. Okay, and this message should be also thrown inside this exception. So what we need to do is to create another test case. Okay, so pop empty stack, this is the test case, then no such element exception thrown equals assert throws no such element exception dot class. Okay, so let's copy the code and then we will explain the code here. So first of all, we need to import this. It's an exception in Java util, so we have to import it. So this test, first of all, we have to add this annotation here. The stack is called stack. So okay, so I have to call it stack. So assert throws, which means that make sure that this test, this execution, this one, stack pop will throw this exception. Okay, and this is the message that you want to print. Then also, so this is the first assert, this is the first test, the second test. So we have two asserts here. We need to make sure that no such element exception is thrown, and then we want to make sure that the message in this thrown exception is equal to stack is empty, can't pop. Let's make sure that this message is exactly what is here. So stack is empty, cannot pop, so it's not the same. So that's why I will copy this one. Okay, so this for sure will not be the same message. Now it's the same. Okay, and then we can execute. I mean, we can run the tests. Okay, so build failure. We run two tests. We got one failure. What was the failure? Test push pop sequence. Okay, so I have to correct this test here so that it doesn't fail again. Okay, so now normally we have two tests. We don't have any error. Why? Because when this was executed, I mean this one stack.pop, we got this exception. Okay, and if we don't, this is what should be printed. Okay, so if I do this, okay, now of course now when we do stack.pop, the exception will not be thrown. Okay, so this means that I mean that's because our test is incorrect. So failure expected, so it's here, our message is here, expected pop from empty stack to throw, but it didn't. This is the message that you have written here. Expected Java util no such element exception to be thrown, but nothing was thrown. Okay, so which is correct, because when we pop here we already have an element, so the exception will not be thrown. Okay, and also if the message is not thrown correctly, I mean if the exception that is thrown is not exactly the exception that we want, because maybe it has another message, it also will fail. And here it will tell us expected true but was false. So the expected true but was false assertion failed error on pop empty stack, which is this test. Okay, so I will correct this. So this is how you test for exceptions that are thrown, and also test that the message in an exception is also the same as the one you are expecting. Finally, test that you pushed elements test that pushed elements are popped in reverse order. Okay, so now we want to, because we want to make sure that the logic of the stack is correct, because in the stack when you push, let's say 10 elements, when you pop them they have to be popped on the reverse order. So we'll call this check reverse order. Okay, of course we have to say that this is a test. Then let's imagine that we have an array of strings. Here I will create an array of strings. I will add I, B, C, D, E, let's say 10 elements, E, F, G, H, I, J. Okay, then I will push all these elements. So for string S, I hope I got this right because I switched from JavaScript to Java, so I think this is correct. So stack dot push S, so we push all these elements. Finally we need to make sure assert equals, what should be equal? So the reverse string, which is J, I, H, G, F, E, D, C, B, A, should be equal to reverse. Okay, so reverse should be for int I smaller than array dot length, I plus plus string reverse equals the empty string, then I smaller, sorry, for int I equals 0. So here we will just append reverse plus equals what is popped, so stack dot pop. Okay, so we pop elements and we concatenate them into this array, into this string, and then finally this string has to be equal to this one. Okay, we can test this. Okay, so the test executed perfectly. Let's say I forgot the B here, or the logic of my stack is incorrect. So I should get an error, a test failure. And the test failure will tell me expected this string but got A, B, C, D, E, F, G, H, I, J. So this is what reverse contains, but what is expected is this one. Of course, this is not what is expected, so the test was correct. Okay, so that's how you can, for example, test for this kind of things. Okay, so that's all with this lab. Thank you very much.